Right, 29. For a polynomial p of x, the value of p of 3 is -2. Which of the following must be true about p of x? Okay, A says x minus 5 is a factor of p of x. B, x minus 2 is a factor of p of x. C, x plus 2 is a factor of p of x. And D, the remainder when p of x divided by x minus 3 is -2. So for 29, yeah, this one is very tricky because it's kind of hard to see where to begin with this one, right? We can't really, you know, we don't know what the function is. We don't know what p of x is. Okay, all we know is p of 3 equal to -2. And we think about the meaning of this, right? P of 3 equal to -2. So that means if you plug in 3 inside the parentheses, that's always going to be the input into the function, right? So when you plug in 3, then what we'll get out of the function, that's the output, is going to be -2. So you can also think of it like when the x value is 3, right, the y value is -2. Right, so that's all we know. Okay, so we know nothing else about the graph or anything about the equation. Um, so if you look at A says x minus 5 is a factor. Okay, so if x minus 5 is a factor, then what we can say is, so then if you have something as a factor, if you set that factor equal to 0, we can solve for x, and this will be the zeros. Okay, so we get x equal to 5. That would be the zeros of the function, which graphically speaking, this is the x-intercept. Okay, so we know on this graph, we have 5 as a 0 or a solution, and then 5 should also be the x-intercept. But again, we don't know that for sure, right? Because all we know about this function is p of 3 equal -2. So 3 comma -2 will be on the graph, but we don't know if the x-intercept is 5. So we can not say for sure. Okay, so A could be true, but the answer says which one must be true. So it's not A because we don't know anything about the factor. So for the same reason, we can eliminate B and C because x minus 2 is a factor. We know x equal to 2 should be a solution. So we should have a point at 2 comma 0, right? That's the x-intercept. But again, we don't know for sure, right? Based on information they tell us, we cannot verify that. Okay, same thing with C. Okay, so just by process of elimination, we know have to be D for the correct answer because A, B, and C we cannot verify. Okay, so what D is, okay, this is an application of the remainder theorem. Okay, this don't show up a lot on the SAT. Okay, but is what the remainder theorem says is we have a function if we divide it by, remember, if we're dividing by x minus 3, right, then we divide this as a factor, we get -2 as the remainder, right? If x minus 3 is a factor, that means the solution when x equal to 3, okay, so the factor, and we set it equal to 0, so we solve that, we get x equal to 3. So it's always kind of opposite, right? So the factor is x minus 3, we get x equal to 3. So that means when whatever we plug in, right, remainder theorem says if you plug in x equals 3, then whatever the remainder is, right, that will be the solution. Okay, so we plug in x equals 3. Since the remainder is -2, y should equal to -2. Okay, which matches with what we said earlier, right? So p of 3 should equal to -2. All right. So the remainder theorem is it's the same as saying x equals 3, y equals -2. It's just a different way of saying it. Okay, so it's saying when we divide by the factor x minus 3, the remainder is -2. So whatever remainder is, that will be the output. Okay. And it's also, some of you might be taking like algebra 2, right? We learn like the synthetic division. Remember the remainder, right? We want to test if x minus 3 is a factor, we can divide it by 3, right? If the remainder is zero, then it is a factor, right? If the remainder is not zero, whatever remainder we get, that will be the output when we plug in 3 into the function. Okay, so that's the concept here. So D is the answer. So once again, we don't see a lot of question on this on the SAT. So this is just, good to know for 29. So it'll be D for this one.